So now you can see here, I think so as we have seen in the last lecture that how to calculate cost. So 3070, how it is, how that cost is calculated. Same for network 50, how that 2174976 that value comes or that cost comes. So for network 50, it will be via 20. So 20, 30, 50, right? So 20, 30, 50 means here it is using fast Ethernet interface from router 0 to router 1, then fast Ethernet interface, and then this we can say serial interface. So again the same formula, 10 raised to 7 divided by least bandwidth plus cumulative delay. So delay is here 10 plus 10 plus 2000. So that is 2020. Right, and that 10 raised to 7 divided by least bandwidth, so that value is 10 raised to 7 divided by 1544, so that value will become 6476 plus 2020, so that is 8496 into 256, so that value will become 2174976. So here you can see, so to reach to network we can say I think routing table that is here, otherwise again we need to give this command. So on router 0 I will give the command on router 0, so that is show IP route. So to reach to network 50, this cost is required, so 2174976. So here we have seen, we have completed that how to configure EIGRP. So transmission is successful. Even you can check, even you can trace the route by giving command on command prompt, that is tracert. So we need to check this IP of this server. So how to reach to this server? So that is, I think this is network 40. So IP of this server is 40.0.0.2. So it, how it reached to this server. So this is tracert command. So that is via 20. So 10, 20, 30 and 40. So this path comes here. So if I switch off this port, that is FA0/1, so FA0/1, if I switch off this port, so now this path is not available. So again we'll check that tracert command. So again on router, that not on router PC, again give the same command. So now the path is changed, that is 10, 60, 50 and 40. So likewise the path has been changed as this interface or this port is off. So this interface, via this interface packet won't traverse. So this was regarding show IP route. So we'll see some more commands of EIGRP. So now in CLI mode of router 0, just exit from this and we'll see some list of commands like that is, first is again exit, and we are in privileged EXSC mode. So here we need to give command like show IP protocols. So show IP protocol, so you can see here that EIGRP10, then EIGRP metric bit as we have discussed in that presentation, that is K1, K2, K3, K4 and K5. So those are we can say 5 K values, but only bandwidth and delay, that K1 and K3 is by default set. Then here you can see that internal administrative distance is 90, external is 170. So you can check the information regarding the routing protocol. Then next command, that is show IP EIGRP neighbor. Show IP EIGRP neighbors. So it will show you the neighbor. So neighbor of that, where we have given that command router 0. So neighbor of that is 60.0.0.1. So it displays the information regarding neighbors. The next is show IP EIGRP topology. So it will give you the information regarding topology. So show IP EIGRP topology. So it gives you the information, the P, that is passive, 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 10, 30, 40, 50, 60. So where it gives that cost also, cost of that link it is giving. So that is show IP topology. Then if you want to check the routing table with the EIGRP entries only, so that is show IP, then EIGRP and show IP route EIGRP. You can give show IP route command as it is, show IP route, and next is EIGRP. So here you can see the entries where only the destinations, or we can say network, which are configured through EIGRP. So 30, 40, 50. If you see in the topology, that 30, 40, 50 are not directly connected. 10, 20 and 60 are directly connected. So 30, 40, 50, those are configured through EIGRP protocol. So EIGRP is configured here. Now the next which we are going to see, that is how to configure EIGRP and RIP-v2 on the same network as which we have in the assignment. So here we can see EIGRP and RIP-v2 topology file, where I have given IP addresses to all the interfaces. Even PCs are configured. So IP address configuration is done. Only that routing protocols are not configured. That's why here that transmission won't be successful. So we need to configure routing protocol. So first we'll configure on these 3 routers, we have to configure EIGRP, and all these 4 routers we have to configure RIP-v2. Means these 3 routers will have RIP-v2 as well as EIGRP. So 2 routing protocols are, you need to configure here on these 3 routers, that router 0, router 1 and router 2, and router 6 will have only RIP-v2. So we'll do that configuration fast. Now what we'll do, go into the CLI mode, and we are on router 0. So total how many networks are there? Again, total 7 networks are there: 10, 20, 70, 10, 20, 30, 40, 50, 60, 70. So total 7 networks. So again, same procedure for this configuration. So you can see, first we'll configure router EIGRP, and I will give autonomous system number 10. Right, so we'll configure EIGRP first on these 3 routers. So router EIGRP 10. So next is we need to add network. So that is 10, 50 and 20. So 10.0.0.0 network 10, then network 20, then network 50. So 10, 20 and 50 we have added here on this router. Then click on router 1. I think we'll add that RIP-v2 also in the similar time. So exit, then router RIP, then RIP what version 2 you can mention here, version 2. So version 2 we need to add, and then same procedure, that is network, or we give just, we have to add the same networks. No? So we can give same command. Now it's version 2. So network 10.0.0.0, then same command we can execute 50 and 20. So on router 0 we have configured RIP-v2 as well as EIGRP protocol. Then click on router 1. router 1's CLI mode. So here same procedure, conf t, then we'll configure first EIGRP 10, then network which are directly connected, that is 30, 50 and 60. So network 30, then network 50, so adjacency is established here, then network 60. So exit from this, again configure router RIP version 2. Then next command, that we need to add the same network, so that is 60, 50 and network 30, which are directly connected. So router 1 has finished its configuration. Then router 2, on router 2, again what we have to do on router 2, we have to follow the same procedure. So conf t, then router EIGRP 10, same autonomous system number. So we are on router 2, so 3 networks are directly connected, that is 60, 70 and 40, right? So network 60, adjacency is established, then 70 and 40. So 40. So we have added 60, 70, 40 on this router. So these 3 routers are having configuration of EIGRP as well as RIP v2, right? So EIGRP we have configured, RIP I think we have not yet configured on this router. So exit from this, then router RIP version 2, right? So we have to add same networks, that is 40, then 70 and 60. So RIP v2 is also configured on the router 2, right? So these 3 routers are configured. Now on this router we are going to configure only RIP v2. So click on the router and go into the CLI mode, enable, then conf t, then router RIP, then version 2, then we need to add the network which are directly connected, that is 20, 30, 40. So network 20, then network 30, then network 40. So 3 networks has been added. Now what we'll do, we'll give command here on first router, that is show IP route, exit. So show IP route. So you can see this router is having both the protocol RIP v2 as well as EIGRP, but in the routing table path shown through EIGRP only. Why? Because EIGRP is having AD value 10 and RIP is having AD value 120. So smaller the AD value, that is the best protocol. So smaller AD value provided by EIGRP, that's why in the routing table or routes are considered through EIGRP only. So 10, 20 and 50, these are directly connected, and 30, 40 and 70, those are connected via RIP. So if you notice here, all the networks are there, 10, 20, 30, 40, 50, 60, 70. So 3 are directly connected and remaining 4 are connected via EIGRP. Now I won't tell you how to calculate the cost, because in the last session we have seen how to calculate the link cost, right? So link cost calculation we have done. So we'll see the transmission now, whether it is successful or not. So it is successful from PC0 to PC1. Then you can check here, router to router even, it is successful. So what we'll do, we'll give the command. Now check the IP of PC, that is 70.0.0.2 PC1. So from this PC, I will give command that is desktop command prompt. So tracert, to trace the root, we have to give this command tracert 70.0.0.2. So path taken, that is 10, 50, 60 and 70. So this is just like a backup router. If any link failure is there, if any link is failed in this case, so it will take this path. So currently it is traversing through 10, 50, 60 and 70. So that path is considered. So what we'll do, we'll make this serial port off. So that port number is serial 0/1/0. So I will make it off, and then we'll check what happens. So now this link is currently off, so this path won't be followed. So again PC0, and on the same command prompt you have to give command tracert 70.0.0.2. so you can notice here, so it is not getting paths. Wait till that updates its routing table. So we'll wait till time. So you can see, again I will give the same command. So you can see the path 10, 20, 40, 70. So 10, 20, 40, 70. So it has not taken this path, right? So we can say that as the EIGRP is having less AD value compared to RIP-V2, then that EIGRP is only considered for path selection. RIP-V2 won't be considered. Now if you have made this link off, so again you can go on the router and go into the CLI mode and give the command that is show IP root. So here show IP root. So if you notice, now this link is off, that serial link is off. So this path is not available. This network is not reachable from the router 0. That 50 is not reachable. So you can observe in the list there are 10, 20, 30, 40, 60, 70. 50 network is not there. And the path followed, that is by using RIP protocols. So even in the routing table, if you notice, D is not there. So it is showing only RIP protocol. EIGRP is not considered here while packet is traversing throughout the network. So you can see 10, 20, those are directly connected to this router, router 0, 10, 20 are directly connected, 50 is down now. So all the networks in the routing table, those are shown via RIP only 30, 40, 50, 30, 40, 60, 70. So 120, 120, that is AD value, and this is hop count, that 1, 2, 2, and via. And this is periodic timer as we have discussed at the time of RIP, right? So here you need to understand one thing. If there are on one router we can implement more than one routing protocol. So more than one routing protocol means here we have configured RIP-V2 and EIGRP, right? So that's why there is EIGRP will have more weightage, or EIGRP will get the preference as the AD value of EIGRP is less than the RIP. So less AD value is better. So less AD value protocol will be considered for transmission of the data. So if that link is failed, even though the EIGRP is installed here or EIGRP is implemented here on next router, that is router 1 and router 2, but if it is not reachable, that protocol won't be considered to traverse the or to transmit the data. So that you need to understand. So that is our assignment, that EIGRP and RIP V2 on the same network. So here you can now notice, if I make this port on, again we'll check. So port is on now currently. Just wait for some time. We'll check the transmission, that is successful. So on the PC again, PC's desktop again, give the same command. So it has taken 10, 50, 60, 70. Initially it was 10, 20, 40, 70. So that is fast Ethernet path is considered. Now it is 10, 50, 60, 70. So even though the serial interface is having less bandwidth here, still because of EIGRP, preference is given to that serial link interface. Otherwise, what happened? Fast Ethernet interface will get the preference. Why? Because fast Ethernet interface is having 100 Mbps speed. And serial interface, if you have not changed bandwidth, that is 1544 kbps bandwidth that serial interface provides by default. So even though the bandwidth is less, but the protocol, because of protocol implementation, if the EIGRP is implemented on this 3 router, it has got the preference. This path has got the preference, that is 10, 50, 60 and that is 70. So here we have completed with EIGRP and RIP V2 on the same network. So this router just acts as a backup router. If anything happens with this link, then the alternative path will be provided by this router, right? So if now we can check, suppose I have serial 0/1/0, I have made this port off, and even that FA 0/1, 1/0, if I just wait, FA, what is the name of that interface? This interface from 40, that is 1/0. If this interface is off, so what will happen? That packet was initially traversing through 10, 50, 60 and 70, but now this link is off. So it was traversing by using 10, 20, 40 and 70. Now, but this interface is also off, that FA1/0. So how it traverses? So we'll check. Traceert 70.0.0.2. So still it is updating its routing table. So we'll give this command again. Now 10, 20. So 10, 20, 30, then 60 and 70. So it's a long route. How the packet is traversing? From PC0, that is network 10, 10 to 20 as both the links are on, 20 to 30 as this link is off, this interface is off, FA1/0, so it cannot traverse through this interface or through network 40. So it will traverse through network 30, 30, then 60, 60 and 70. So this path is obtained. So some alternative paths are available. So router make the changes. So now we'll see the routing protocol used. Definitely the routing protocol used here is EIGRP, as that link is off. That is serial link is off. That's why EIGRP won't work here. So show IP route. So show IP route. So you can observe, as two networks are not there, so 10, 20 directly connected. That network 50 is directly connected, but that is off. That's why it is not shown. So network 50 is not there. 40 is off. So 40 is not also there. So 30, 60, 70. So those are connected through RIP. So here, so today we have seen that EIGRP RIP V2 on the same network, as well as only EIGRP topology that we have seen, and how to calculate the cost with the help of example, I have explained you that how to calculate the cost in case of EIGRP protocol. Then we have completed TCP bus, that is solution, and there we have completed with the fifth unit, that is TCP bus. Right. So in the next lecture, we'll see